Now that we've learned how to create crosstabs with single samples in multiple categories, we're going to add in multiple samples. Now, in most of market research, you will actually be working with multiple samples as you conduct your studies. The samples may be different market segments. They could be different demographic variables. They could be different locations. So as we do this, you'll be learning how, as a market researcher, you'd actually be representing this kind of data, categorical data. We're going to represent it with bar charts using multiple samples. At the completion of this section, you should be prepared to do morning or evening, male or female, or Starbucks study, almost. There's one more part you need to know before you can complete those exercises. So here's an example of already converted data from raw into numerical data of two samples. The sample collected in front of DePaul here, the sample collected from the data collected from a sample in front of the Federal Reserve Building here. We're going to go ahead and create the crosstab table, the crosstab plot directly, rather than force you to go through and convert the raw data of words into numbers once again. So we're going to go ahead and insert our 100% stacked bar chart here. There we go. And now I'm going to select my data, add, series name, never. Now I'm going to take the series values from both DePaul and the Federal Reserve. And you notice two groups came up. One for DePaul and the other one for the Federal Reserve. Okay. I'm going to add the next one. Series name once a year. Series values. This. Just continue to work through this. You see, I'm just collecting my series names and my series values. Finally, I have all of my series that I'm plotting in there. I just need to determine which group goes where. So I'm going to select my data labels. My data labels collected, my series data and names have been collected. I can let it rip. And we have a beautiful looking little plot. Again, using the quick tool from Excel on the chart layout, I'm going to go ahead and insert the crosstab table there at the bottom. Let's change the title to represent the data that was represent the question that was being asked, so people will know what we're plotting here. And we're going to just call this hot dog eating frequency. And we have now the hot dog eating frequency at the Federal Reserve and in front of DePaul. I'm going to change the way it plots, some sort of gradation scale. Choose that color. There we have it. It's nicely plotted with a bar chart, 100% stacked bar chart. I'm going to stretch this out just a little bit to make it more clear as to where the data is. 100% stacked bar chart, nicely plotted, and there's also my crosstab table at the bottom. We have now created crosstabs from categorical data. You should be able to work through most of the exercises in the back of the chapter, not quite all, and not quite all of the steps. So now that we have this plot of the data, we understand that Federal Reserve people tend to say never more often than DePaul. DePaul seems to have a few more people that eat 2 or more times a week than the Federal Reserve, quite a few more people that eat once a week than the Federal Reserve. It'd be nice if we actually knew the average category incidence frequency of the Federal Reserve people versus DePaul. To do this, what we have to do is convert our data here into a weighted average category incidence frequency. So let's first go ahead and insert another column here. We're going to call it interpretation. And we need to use a common basis. Since my largest group over here is year, I can use years as a common basis, months, or weeks. It'll be easiest if I use the common basis of the largest group. So I'm going to interpretation on a yearly basis. There we have it. Wrap text. There we have it. And never would imply that they eat 0 hot dogs a year. Once a year would be 1. Once a month would be 12. Once a week would be 52. 2 or more times a week would be 104. Using a weighted averages, we can calculate our category incidence frequency using the sum product of the number of people who said which response times the meaning of those responses divided by the total number of responses within a sample. Getting rid of the unnecessary decimal points, we find the average DePaul student eats 27 hot dogs a year. I'm going to put the dollar signs in the part that I need to hold constant. This time I'm going to copy it from column to column, so I need to put it in front of the column letters of specifically the interpretation, not the actual data. So there we have it. The green stuff is being held constant. The blue stuff is allowed to change. Copy, paste. We see the Federal Reserve people eat fewer hot dogs than the DePaul people. Very clear way of describing the average category incidence frequency yearly on an annual basis. We've taken a look at a number of different measurements of categorical data, and in Chapter 2 we also looked at numerical data. And one of the issues that we kind of tripped across was how the sample is designed and why are we doing sampling to begin with. I mean, wouldn't we get a more accurate measurement if we measured everybody as opposed to just a sample? Well, yes, you would get a more accurate measurement. However, we have a basic challenge of cost. Consider, for instance, the 2010 census. That cost the U.S. taxpayer roughly $14 billion. Very few market researchers have $14 billion to go and survey everybody in the U.S. Nowhere close. Our budgets are tight, and we can't quite do that. So rather than surveying everybody and conducting market research, we'll survey a sample. Now, determining a sample, the first thing we're going to have to worry about is how large that sample needs to be, or the sample size question. When it comes to sample size, obviously the larger the sample size, the more accurate the measurement. But there's a trade-off. The more larger the sample size, the more expensive. So how large is large enough? How small is too small? Well, there isn't a single answer to that question. But I'll give you an example of the trade-off. For instance, suppose there are 1,000 people were surveyed saying, should the U.S. open its borders to Canada? And 51% of those 1,000 people said yes, and 49% said no. Well, we have an issue of accuracy. Is it exactly 51% for the U.S. overall? Are those 1,000 people completely representative of the U.S. overall? Probably not. There might be some questions of overall accuracy. So the 51% measurement with 1,000 people responding actually has an error range of plus or minus 3%. That means that maybe 54% of people thinks we should open the border. Maybe only 48% of the people think we should open the U.S. border. Is it exactly 51, 48, or 54? It's somewhere in the range of 48 to 54. We don't know if most people agree or disagree. It's too hard to measure. Suppose we wanted to get more accurate. Reduce our error range down from 3% to 1.5%, or cut our error range in half. we'd have to increase our sample size by a factor of 4. That is, to cut the uncertainty in our measurement by a factor of 2, we have to increase the sample size by a factor of 4. That would imply we're not surveying 1,000 people, but suddenly 4,000 people. And even at 4,000 people, our error range would still be 1.5%. That means we're not sure if it's 51 or 49.5. We could still find out that overall Americans are against opening the border with Canada. Again, this is purely a hypothetical study. How do we improve it? Well, we could try to reduce our uncertainty down to a factor of 0.75%. That's less than 1%. That would imply increasing our sample size by, again, another factor of 2. So, our sample size now becomes 8,000 Americans. 8,000 Americans could tell us 51% plus or minus 0.75%. That would tell us the difference between 51, a majority, and a minority agreeing to the statement. Of course, surveying 8,000 people is 8 times more expensive than surveying 1,000 people. So we have a clear trade-off in terms of cost and sample size, and therefore accuracy. We find for many research projects, a sample size of 1,000 is more than adequate. A sample size of 50 is used in some research works. 300 is very common as well. Somewhere in those range. But what is the exact number? Well, it depends upon the cost of adding more people to your sample size. The next issue we need to look at in terms of measurement accuracy is representation. The results we get from a survey are clearly going to be dependent upon the people we're surveying. How representative is my sample of the overall population I'm trying to measure? For instance, if I'm trying to measure the hot dog eating frequency of a student, sampling students would probably give me a good representation of the measurement I'm trying to get. But if I'm trying to measure, for instance, the insurance purchasing habits of retired Americans, surveying students would not give me a good representation of the behavior of retired Americans. So in sample design, since we can't measure everybody, we have to do a sample. And in sample design, we have to think about both the size and the representation. Is the representation of the sample match the representation of the population we're trying to measure? And is the size large enough to give us a sufficiently accurate measurement? Total precision is off the charts. We can't afford it. So we'll just take a measurement that is within some level of accuracy, which is obviously impacted by the representation of the sample studied. For more discussions about sampling, sample size, and sample representation, I suggest you examine a standard market research text. Now, if we look at different samples, we're going to find different means. Well, what is the overall population mean if you took the same measurement and found 5 different means or 4 different means? To find out, we once again will use weighted averages. In the next Excel exercise, I'll show you how to do a weighted average to calculate the mean of means. An example of this will be shown in the exercise at the end of the chapter on plastic injection molding. After you complete this next portion, you should be prepared to execute that particular exercise. So here we have an example of a need to take a mean of means. We have 4 different samples. This sample has 95 people in it, and their average is 42.5. This sample has 153, and their average is 43.7. This sample down here is 133 with a sample average of 43.3. So we have different sample sizes, because different researchers did the sample. We have different means. Well, who's to say what the actual average mean is? Well, to find the overall average, we simply take a weighted average. This is equivalent to saying 95 people gave a response of 42.5. 153 people gave a response of 43.7. 78 people gave a response of 41.8. And 133 people gave a response of 43.3. We can find the overall average, again, by taking weighted averages equals the sum product of, here's the sizes, or the response frequencies, here's the averages, divided by the sum of the averages. So in a sense, this is the number, the frequency of getting an answer, and those are the answers. And I'm taking a weighted average of the answers by the frequency of getting those answers. We find our overall average was 43. And 43 is somewhere between, the minimum, 41.8 and 43.7. So the overall average among all of these samples, the total size of that, would equal the sum, what's above it. The overall average of 459 responses is a 43.